morning, everyone. Please stand up. Good morning. Have a seat. Thank you. Have a seat. Thank you. And please open up your notebooks and please copy the agenda. Friction acts in the same direction as an object's motion. Is this true or false? What do you think? This is false. Okay, so now it's your turn. I'm gonna call someone out and please tell me if you think it's true or false. The soles of your shoes and tires on a car have threads to increase friction. What do you think, Sunny? Absent. Okay, Sunny's absent. Check. Okay, let's ask Jessica then. True? Okay, you think it's true. That is correct. So the soles, these are the soles of our shoes. What are they made of? Rubber. You can have a seat. That's the key. So they're made out of rubber, and rubber is not slippery. Rubber sticks to the ground, right? So if something sticks to another surface, that means that it has high friction. Okay, so that is true. Let's go to the next one. A wet surface is less. Do you think water resistance is stronger or weaker than air resistance? Who can tell me what they think? Okay. That is correct. Yes, water resistance is way stronger than air resistance. Can you think of why? What's the reason? Okay, again.
There are more molecules in water than air.
Yes, there are way more water molecules in water than air. That is exactly what we're talking about here. Water has a stronger drag force because water is more dense. There are many more particles, and an object passing through water will hit those particles. Okay, now is worksheet time. Let's do that. So the first step is the first thing you need to do is complete the true or false part. Let me see if I can show you here. Yes, you need to complete the true or false. Let's do the first one together. For example, friction opposes the relative motion between two surfaces in contact. That is true. Okay, so let's do that first. Fill out part one first. We will do a little exercise and then we will continue. Okay, all right. Okay, let's do a little bit of vocabulary now. What does complement mean? So let's do this one. Friction complements the relative motion. Yeah, so there's some somewhat advanced vocabulary here. We have, where's nuclear fusion? Which number was it? 5A, okay. Friction causes nuclear fusion. Okay, nuclear fusion is related to chemistry. Okay, is when why do we use lubricants? Okay, I have an example here. Imagine we have this door, and here, if this gets rusted, it starts making a lot of noise, right? if the hinge gets rusted. So what do we put in there to make it move better? Anybody? Oil, right? So oil in this case is also a lubricant. So oil is a lubricant. It's anything that allows less friction between objects, like oil does inside a machine. Okay, so I'm gonna take this example here. So which one moves more freely? If I barely touch the object and I move it like that, it's very easy to move, right? But if I put a lot of force, if I push down and I try to move it, it's harder to move, right? Because there's more friction. The more force you put into something, the more friction there's gonna be. It's gonna be harder to move. So that's what it's saying here. Friction depends on the force between two contacting surfaces. This is wood surface, and this would be a plastic surface. Okay, good job, guys. So now let's move on to this part of the worksheet. Please fill it out. Use the words that you see at the bottom here. Complete the missing words in the paragraph using the word bank. You may use some of these words more than once. Please fill it out and be ready. I'm gonna call some of you and you're gonna fill it out here in front of the class. Okay, is everyone ready? Let's check if you guys filled out your work. Let's see. Good here. Okay, good job. Are you done with the other side? Okay, let's finish this because I might be calling you, okay? So you need to know that part. Okay, let's fill this out really quick. You can help each other, okay? If you don't know, if you get stuck in a part, please ask your partner, or you can also lift your hand. I'm more than happy to come and help you out, okay? But please fill it out. You have 1 more minute, and then I'll call some of you to fill it out here. Okay? Yes. Oh, you want to check if it's correct? We'll check everybody together. We'll check everybody together in a moment. But do you have a question about anything? Not yet? Okay, right. 4 people, so I'm going to call 4 of you. The first one, please come to the front. Is going to be Olive. Olive, please fill out the first sentence. Okay, everybody changed places, so I'm not sure where you're sitting, but Olive's going to do the first one, please. And you can grab chalk. And then we will have Lucy, please do the second sentence. Lucy's gonna do the second one. Lucy's here, right? Where is she? Okay, Lucy. Yes. And Lucy, and then we're gonna have Stephen. Stephen do the third sentence. Stephen, please stand up. Yes, okay, do the third sentence. And one more. And then we're going to have Laura. Laura, please do the last one, the fourth sentence. From here to the end. Yes, okay. And we have a fish with no food. A fish with food. Okay. Alright. Okay. Now let's check our answers. Let's see if this makes sense. Air and water resistance are types of frictional force, which is a drag. Okay, I think you guys need to flip this one. So it would be our types of drag, which is a frictional force. Okay, so just change the positions on these two, but you got the right idea. So that's great. Because they are very much related, right? Frictional force is a type of drag, and drag is a type of frictional force. Anyway, these are caused when an object moves through air and water. That is correct. Good job. And the next one, it says the particles. Okay, the particles. I'll just add an answer. The particles hit the object and slow it down. Very good. So if you have an airplane, or you have a fish, or even if you have this block of wood moving really fast through space, then there are going to be particles that hit it, right? And make it slow down. So that is correct. Objects experience resistance as they move. That is correct. The faster the object moves, the greater the resistance becomes. So you guys did an excellent job. Very good. Thank you. Yes. Oh yes, yeah, let me do that there. So we need to move this over here. This is gonna be drag. This is drag. And it's gonna be a frictional force. Okay, please check your work, make sure that you have it filled out correctly. And now let's move on to the next part. What would you need to change? Which area do you need to change in order to make it more streamlined? Let's check. So draw circles on the area that you think need to be streamlined. Very good. Good. Lines. Can you guys give me some objects or animals, vehicles, anything that is very streamlined? Give me an example. I'll give you one example. An animal that is very streamlined is a fish. Fish. Very streamlined. Why? Because the water hits the fish when it's moving, and the water goes around the fish. Right? Can you give me any other examples of very streamlined objects? Okay? Paper plane is streamlined? Okay, good job. Yes. Yes, that's true. Any other object that is very streamlined? What's that? A bicycle? Oh, maybe a racing bicycle. Have you noticed how thin the tires of a racing bicycle are? If you look at it from the airplane, yeah. An airplane is also streamlined. Why? Because the air particles hit the airplane and the molecules go around. So it can travel faster in the sky. So that's what streamlined means. Now let's go over the next part of our lesson. And let's watch a video about buoyancy.
The results might surprise you. I hope you have fun trying this out. And thanks for watching this episode of Things Explained.
Okay, so if I have this object and this object, especially if I move it around, which one do you think is going to fall faster? Yeah, this block. Why is that? It's more dense? Okay, that's one good answer. Anything else? This one has. So what do these things, especially if I move it fast, right? What are these little wings doing to the object? The air, right? There's air resistance that is pushing. Air resistance is pushing against these flaps and making it fall at a slower speed. So I think you are correct. And let's test that. Let's test that idea, and I'm gonna call two people and let's test it together, okay? Let's call Jessica and Jeff. Jessica and Jeff, please come to the front. Okay. Here, can you tell the difference? Which one fell faster? The block of wood, right? Okay. Yes. Okay, but what do you think would happen if I would get rid of air? If there was no air particles? Imagine we pull the air that we have, suck it out. Do you think in that case both objects will fall at the same time? Yes? Okay, we're gonna watch a video about that idea. So let's look at what happens to air resistance in a vacuum. So let's watch what happens in that situation.
Accelerated towards the earth. So he concluded they weren't.
Okay, so can anyone tell me when they got rid of the air? So let's look at that idea first. Imagine that this is that chamber, right? And they have the bowling ball and they have the feather, right? What did they do so these two fall at the same time? What did they do for that to happen? They pulled out all the air from the chamber. So they grabbed a pump, they had a tube, and all the air that was inside the chamber went inside the tube outside. So that's the first thing they did. They got rid of all the air from the chamber outside. And when that happens, this is called to have a room in a vacuum. In a vacuum means that you don't have any air. In this room, we're not in a vacuum. Why? Because it's full of oxygen particles and other elements in this hydrogen, etc. Right? Shown there. Okay. We are done, but next time we will go through this, the last part. Please everybody stand up. And thank you so much for today's class. See you next time.